Welcome to another exciting educational video brought to you by Up Vision Concept Academy. So today we'll continue in our series of math questions, Coordinate Geometry Part 2. Started the Part 1 in the last lessons where we did with question 1 to 5. So we're going to be proceeding to question 5, question 6. If you are here to see the video of the previous uh, installment, you might go cut our video on Coordinate Geometry Part 1, where question 1 to 6 was solved. So we're going to be starting from question 6. We stopped at question 5 in the last video. This one says find midpoint of minus 4 and 2. This should be a minus 4 and 2, and 6 and minus 8. Okay, so we dive in. Like I said in the first video, the first thing you do is to identify your coordinates and the particular coordinate that you are referencing. So this is minus 4 and 2, and there I have 6 and minus 8. So this minus 4 is x1, and 2 here is y1. This 6 is x2, and minus 8 here is y2. So there's a formula for midpoint. So midpoint formula is x1 plus x2 over 2 and y2 plus y1 plus y2 over 2. So you see that this first coordinates, the formula there is minus 4 plus 6. That's this minus 4 plus 6. Minus 4 plus 6. So I'm referencing x2, x1, and x2, right? So minus 4 plus 6 over 2. And the second coordinate in the midpoint is 2 and minus 8. So 2 minus 8 over 2. Okay. So you get minus 4 plus 6 over 2 is 2 over 2. That's the first coordinate. And 2 minus 8 is minus 6 over 2, which is minus 3. So I have 1 and a minus 3 as the final answer for the midpoints of these coordinates. Okay, so find the gradients of the functions. You have the gradients. You have x1 and y1, then x2 and y2. Again, the formula for the gradient is um, m is equals to y2 minus y1 all over x2 minus x1, right? So identify which one is y2. So y2 is minus, 3 over 2. 3 over 2 is y2. This is y2, right? That's why I'm having it here. Minus, then y1 is this one. Y1 is this one. That's 1 over 3. Minus 1 over 3. So minus 1 over 3 all over x2 is 3. This is 3 here. This is 3 here. And x1 is minus 1. Okay, so I've put it in the formula here. So what I have at the top, 2 over 3 minus 1 over 3 is 2 over 3 plus 1 over 3. That will give us 1, right? Then 3 minus 1 over 2 will give us 5 over 2. So by the time you do the math, 1 divided by 5 over 2 is the same thing as saying 1 times 2 over 5. So the answer is 2 over 5. The gradient between those two coordinates is 2 over 5. So this is equation through a point. It says find equation of line with gradient 2 passing through 1 and 3. Find equation of a line with gradient 2. So the gradient is 2. If this is the line, y is equals to mx plus c. Gradient is 2. So is y is equals to 2x plus c. Now, to get this C, because I cannot write C on the formula. I need to find what I need to use this coordinates, put them here where x is 1 and y is 3. So I have 3 is equals to 2 into 1 plus c. So 3 is equals to 2 plus c. 3 minus 2 is equals to c, and c is equals to 1. So if I have c as 1 and gradient as 2, I can write this as equation of line y is equals to 2x plus 1. So this is the equation of that line passing through that coordinate. Okay, so distance with negatives. Find the distance between, again, this is -1, 4, and 3 and 1. So these are the coordinates. So the distance between the two of them is y2 minus y1. So not minus, okay, sorry, distance is equals to square root of y2 plus y1 all square plus x2 plus x1 all square. So what is x1? What is y2? What is y1? What is x2? All right, so x2 here is 1, so I have 1. y1 is 4, I have 4 all square plus x2 is -1, so I have -1 plus, no, sorry, x2 is 3, sorry, so I just have 3, then plus -1, all right, all square. Okay, so 1 plus 1, 1 plus 4 is 5 square. For this is also square root. D is equals to square root again. So 1 plus 4 is 5 all square plus 3 plus -1 is same thing as saying 3 minus 1, which is 2. 2 all square, right? So D is equals to square root of 25 plus 4, which is root 29. So the distance between the two of them is root 29. Okay, there's a little bit of a mistake here. Let's see. Let's try and trace what the problem is. Let me erase this one first. Formula is still correct, but I'm sure when we started substituting, we had an error. Okay, so this is the formula. The formula is D is equals to x x2 plus x2 plus y2 all square plus x1 plus y1 all square. Okay, so that's what we have here. Yes, x2 plus x1 all square plus y2 plus y1 all square. Okay, so by the time you put it, so you're adding this and this and squaring. You add this and this, then you square, right? Okay, so by the time you add this and square, you'll be having 1 plus 3 is 4. 4 square is 16. And by the time you add 4 and -1, you have 3. 3 square is 9. So 16 plus 9 is equals to 5. So 5 units, 16 plus 9 is 25. So square root of 25 will give you 5 as final answer. Okay, so zero gradient. What is the gradient of the line touching or joining 2, 7 and 9, 7? Gradients of the line. So this is just gradient again. So this is the formula for gradient. Remember, m is equals to y2 minus y1 over x2 minus x1. Again, identify which one is x1. So this is x1. This is y1. This is x2. And that is y2. Okay, so we just put them in this formula. translate to this, and then you get 0. So 0 is the gradient. Parallel lines. So find the equation of the line y parallel to y is equals to uh, 3x minus 5 and passing through 2 and 1, coordinate 2 and 1. Okay, so first of all, the equation of the line parallel, there's a condition for parallel equations, parallel line. The gradient of the two of them are the same, right? So parallel lines have the same gradient. So if I want to find the equation of this parallel line, I just the gradient is already 3 because this line parallel to this means that the gradients are the same. So if this is 3 here, the gradient here will also be 3. Will also be 3, right? So that's why I'm having it here. So I'm going to get C from these two coordinates and the gradient. So I just put it in the formula for a gradient. Y is equals to mx plus C. I know that gradient is already 3. So, and y is given to us as 2, and x is given to us as 1, right? I'm just putting them in the equation directly. So plus C to get C, right? 2 is equals to 3 times 1 is 3 plus C, and the uh, C will be equals to minus 1. C is equals to minus 1, right? If C is equals to minus 1, I can now come here and write this equation as y is equals to gradient is 3x minus 1. Find the equation of the line perpendicular to y is equals to 2x plus 1 passing through 1 and 4. So given the gradient as 2, gradient is 2, right? That's 2 from here. Perpendicular gradient is minus 1 over the other gradient. So this is condition for perpendicularity. M is equals to minus 1 over m2. Okay, let me call this one m1. So if you have two lines, the gradient of the first line 1, which is m1, is equal to the gradient of the inverse of the second line, negative, right? Okay, so having gotten that gradient for the second line, I can now put it in this equation. Y is equals to mx plus c, where the m is minus 1 over 2. That's why I'm having it here. This is 4. 4 from here. This is 4 from here. And this is uh, x from here, right? C is unknown. So I can find C. C is 9 over 2. If C is 9 over 2, I can put it back in this equation. And I know that I have my m as 1 over 2, right? So, put it back in that equation where I have y is equals to mx plus c. The m is already given as minus 1 over 2 from here, and the c is already given as 9 over 2 from here. So this is the answer. I can even simplify it further. I can even just say from here, multiply each term by 2. So I have 2y is equals to minus x plus 9. But otherwise, I can leave it here, making x y as a formula, right? Okay, so the midpoints A is 2 and 4, and B as x and 8 is 5 and 6. Find x. Find x. So this is the midpoint of these two coordinates. So you know the midpoint formula. X1 plus x2 all over 2, and y1 plus y2 all over 2. This represents the coordinate of the midpoint. So if this first coordinate of this midpoint, this is the midpoint coordinate, this bracket here, midpoint coordinate. If this one maps to 5, this one maps to 6, right? Then I can equate this to this, and equate this to this. So it means that 2 x1, 2 plus x all over 2 is equals to 5. This is what I'm interested in. This is the equation, right? So this times this is 2 plus x is equals to 2 times 5 is 10. So x is equals to 10 minus 2. So x is equals to 8. So that midpoint, this x is given as 8, right? So it says find the value of k if distance between this, that is between 1 and 2, and k and 6 is 5. Okay, so again, we are to look for the formula that satisfies uh, distance. That the distance formula is d is equals to square root of x plus 1, x plus 2 all square. Sorry, y1 all square plus x2 plus y2 all square, right? Okay, so let's go with the flow. So k here, k2, that k is y1 and x1. These two, you have it as k minus 1, k minus 1 all square. Then this is 6 minus 2 all square, right? Then they are all having the square roots on top of them. So, and it's equals to 5. So I can now square both sides to remove the square roots. Square both sides. 5 square will give us 25. And I have k minus 1 square plus 16. So 16 will go this way. So I have 9 here because 25 minus 16 will be 9. So this one too, k minus 1 square is equals to 9. By the time I square both sides again, find square root of both sides, I will have k minus 1 is equals to 3, right? 3. So either, yes, this is k minus 1 also plus or minus 3. So either k is 4 or k is minus 2, depending on the sign you are using. If you are using positive, when that's positive 3, when minus 1 cross over to the other side, 3 minus plus 1 is 4. Okay, and if you're using negative 3, if minus 1 crosses and becomes plus 1, minus 3 plus 1 is minus 2. Right, so there are two solutions. These two solutions came because I have plus and minus 3 here, right? Because when I find square root of both sides, my solution will be positive or negative because they can both of them can give you large square roots. Okay, so the next one is equation of line through 2 points. Find equation of line through this point 1 and 2 and 3 and 8. So equation of line again, this one you find the gradients. When you find the gradients, then you now find the uh then you now use one of these points to write the equation. Like this or this write the equation. Okay, so let's go. So the gradient is 3, and if we are to use the first one to find intercepts, you see that by the time you put x as 1 and y as 2, you will get c, because the range is already given as 3, right? So you get c. C is minus 1. So by the time you put in the equation of the gradient, we have y is equals to 3x minus 1. Okay, so now this one says determine whether the lines through minus 1, sorry, 1 and 2 and 3 and 6 and 0 and 1 and 2 and 5 are parallel. What do you need for this particular question? What you need is to prove or show that the gradient for this and the gradient for this are the same. So if this is equals to this. Line 1 gradient and line 2 gradient are the same, then the lines are parallel. So find the gradient of the first one. The formula for the first gradient is m1 is equals to 6 minus 2 over 3 minus 1 is equals to 2. Formula for the second gradient, m2 is equals to 5 minus 1 all over 2 minus 0. Everything, both of them are giving us 2. So it means that the lines are parallel. Yes, they are. Okay, so perpendicular. So there's perpendicularity. Are lines with gradient 4 and minus 1 over 4 perpendicular? Yes, it is, because uh this satisfies it. If I have m1 and m2 because of minus 1, if you multiply the two gradients and they give minus 1, it means they're perpendicular. And of course, that's what is happening here. So the final answer is yes, the both lines are perpendicular. So midpoint. Find distance from midpoint 2, 2 and 6, 8 to origin. So distance of this point to origin, from the midpoint to origin. So first of all, you will get the midpoint coordinates, and you will find a line between the midpoint coordinate and the origin, the distance. Okay, so midpoint for these two is 2 plus 6, 2 plus 6 first point over 2, and 2 plus 8 second point over 2, right? So the midpoint, the first point here is 4, and the second one here is 5, right? So that's the midpoint. So we're going to get the distance between this midpoint and the 0 coordinate. So it is 4 square plus 5 square, all square roots. That will give us root 41. Okay, hope you understand why we are using just 4, because this is distance between, what we are looking for here is distance between 0, 0 and 4, 5, right? So distance is given as uh, this minus this, 4 minus 0 all square, plus this minus this, 5 minus 0 all square, then all square roots. So of course 4 minus 0 is 4 square, plus 5 minus 0 is 5 square. So that's how we got to this point, right? Okay, so find the equation of the line through 4, 2, 4, comma 2 and 4, comma 9. So these are two set of coordinates. So equation of the line running through. Again, just okay, note that you have 4 and 4. X is 4 and 4. That means the lines are on only x axis. They are running vertically on x axis, because the x is 4. Okay, let me just do this. This is the coordinates. Okay, so this is 0.4. So the first coordinate is 4, right? And 2. So this 0.4 and 2, right? 0.1, right? Second one again, 4 and 9. So 9 is somewhere here, and I take it. So this is 4 and 9. So it means that I'm just looking at this line, vertical line. So this equation is very, very dicey. Very, very dicey, because there's no slope. There's no slope. So both lines, both x values are same. So vertical line. So x is equals to 4. That's the equation of that line. X is equals to 4. X is equals to 4. There's no y. There's no y, and there's no c. X is equals to 4, right? Because the line, the line is on only 4. So find the equation of line through 1 and 7 and 8 and 7. Again, this is horizontal. Let me show you from the Cartesian plane. So the first coordinate is 1 and 7. Okay, so this is the point here. Let me call it point A, 1 and 7. The second one again is 8 and 7. So this is 1, and I go to 8 here. Then still 7, 8 and 7. So I click the line here. This is B point 8 and 7. So the line B It's just in between these two, just like this. So it's vertical, sorry, horizontal, right? So the equation, again, I don't have a slope, but I have y is equals to 7. I have y is equals to 7 because it's just tracing to this side. Okay. So determine if points A, 1 and 2, points B, 3 and 6, point C, 5 and 10 are collinear. Okay, so what's the meaning of collinear? Collinear means that if I get the gradient A and B and B and C, they are the same, it means they are collinear. So if I represent the gradient of A and B as MAB or subscript AB, I have the gradient as 6 minus 2 over 3 minus 1 from these values now. 6 minus 2, 3 minus 1, right? And for the gradient will give me 2. For MC, MC is this one. So 10 minus 6 over 5 minus 3 will give me 2 again. So it means that they are collinear. So you need to know the condition for collinearity. Collinearity and perpendicularity are similar in terms that the comparison is that the gradients are the same, but the conditions are different quite though. For perpendicular, so for parallel lines, the gradients are equal. For collinear, it means that uh, the gradients of this line and this line are the same. Okay, so question 22 says find equation of a line with x-intercept 4 and y-intercept 2. Okay, so use intercept form. I have x over 4 plus y over 2 is equals to 1. So you see that if we multiply each term by 4, we'll get this equation. X plus 2y is equals to 4. So distance, find unknown coordinates k if distance between k and 3 and 1 and 5 is 5. Okay, again, distance formula is used to find the equation, to find the unknown k, right? So we just write the distance formula. So this is k1. So I have x minus y and 3 7 minus 3 3 minus 7, sorry. So this is the formula. So it equals to 5. So 5 is the distance between the two lines, right? So you take the square root of both sides so that you can remove this square root sign. Square root of 5 is 25. So 16 will go this side to mean 25 minus 16. That will give us 9. And this will remain as k minus 1 square. So either x 4 is equals to k is equals to 4 or minus 2. Why? Because by the time you put the square root here, it is plus or minus, right? Okay. So find k if midpoints 2 and 4 and k and 6 lies on the line y is equals to x plus 1. Okay, so this is how the formula looks like, midpoint. So you have midpoint k plus 2, k plus 2, 2 plus k, sorry, over 2. And this other one is gotten from 6 plus 4 over 2. 6 plus 4 is 10. 10 over 2 is 5. So that's how this one is gotten. So this is the midpoint. So this midpoint coordinates, we want to look for k inside of it, right? And this midpoint lies on this line, So this coordinates actually interacts with this line. Okay, so what do we do? So we substitute into the line equation. Uh, the y from this midpoint is 5. Y is equals to 5. And x is equals to 2 plus k over 2. So by the time we put them in this equation, y and x then plus 1. That's, we'll put them in this equation. Y is equals to x plus 1. This one. I'm putting what we have here inside this equation, right? Give us this. So I have 5 is equals to 2 plus k over 2 plus 1. All right, so I can make k the formula. If I simplify, I get k as 6. Find the gradient of a line perpendicular to line joining 2, 3, and 6, 11. So find the gradient of a line perpendicular to line joining. So this line perpendicular, this line, find the line of a line perpendicular. So this one now, if this one is the equation of the line I'm looking at, 2, 3, and 6, 11. Understand? If I get the gradient of this one, the gradient of this line, whatever I get here, let's say equals to m1, I will come here and say it is minus 1 over m2. Okay, so let's go and solve it. So the gradient of that line is 2. That means the perpendicular gradient is 1 over minus 2, right? So that's just it. That's just the answer. Find the equation of the line with gradient 4 passing through 2 and minus 1. Okay, so when you put the gradient equation, the of a straight line is y is equals to mx plus c. Already m is 4, gradient is 4. That's why I have this one now. So I can find intercepts by the time I put y as 2 and x as 1 minus 1. I can find intercepts. So I got my intercept as minus 9. So I have y is equals to, the gradient is 4, x minus intercept is 9. All right, so y is equals to 4x minus 9. So let's find the area of a triangle with vertices 0, 0, 4, 0, and 4, 6. So this one again, I can just draw my Cartesian plane like this. So the first set of coordinates is 0, 0. So this is 0, 0. This dot here, let me call this dot A. So I'm calling this one A, B, and C. So for B, it's 4, 0. So the x is 4. Along the x, I have a 4. Along the y, I have a 0. So it's still resting on that line. This is point B. And point C, along the x is a 4. This point again. Along the y is a 6. So let me say 6 is here. So I just do my dotted line here. Put point C, which is 4 and 6. Right? So this is point C, which is 4 and 6. So this point now is C. So I can join them together. So if you check closely, this is forming a right angle triangle where this is 6, side 6, and this is side 4. Because between here and here is 4, between here and here is 6. So I have a right angle triangle, and so I should find the area. Area is half base times height. Half times base is 4 times height is 6. 2 here 1, 2 here 2. 2 times 6 is 12. So 12 units square is the answer to this particular question. Okay, so find the point of intersection y is equals to 2x plus 1, y is equals to 2x plus 1, and y is equals to minus x plus 7. Intersection means that you are going to equate this and this, right? So equate it. So I have 2x plus 1 and x minus x plus y. 2x plus 1 minus x plus